So I was assigned question 10b, which is find the point elasticity of demand equation and determine whether the demand is elastic, inelastic, or unit elastic. So here we have P equals 3000 over Q, and then they give us the variable Q, which is equal to 300. So to solve this problem, we're going to use eta P. Let's write this down. Yeah, my eta sign isn't the best. Eta to the P equals P over Q over the derivative of P. So the first step we're going to want to do is find the derivative of P. So here we have P1 equals derivative 3000 over Q. So first thing we're going to do here is take out this constant 3000. So now we're left with 1 over Q, which can be rewritten as, to make our life easier, be rewritten as Q to the negative 1 power. So now we're going to use the power rule to find the derivative of this. So we have 3000 times negative 1 Q to the negative second power. So when you multiply that, you get negative 3000 over Q squared, because we brought that Q to the denominator because we want it positive, make our life easier, make things easier. So now we have that. We can plug all of this into the eta equation. So here we have 3000 over Q divided by Q divided by the derivative of P, which is negative 3000 over 300. Oh, whoops. Over Q squared. So they give us the Q, which is equal to 300. So now we're going to plug in that Q to see if our demand is elastic, inelastic, or unit elastic. So here we go. We have 3000 over 300 divided by 300 over negative 3000 over 300 squared. So here we get 1 over 30 over negative 1 over 30. That's going to give us negative 1. So now we have to find the absolute value of that to determine whether it's elastic, inelastic, or unit elastic. So the absolute value of negative 1 is obvious 1. So the rule here says when eta is equal to 1, that looks more like an N. When eta is equal to 1, that means our demand is unit elastic. So here we have, so therefore, demand is unit elastic when Q equals 300. So here is our answer, and here you can see the equation this is our equation right here.